Climate scenario analysis relies heavily on globally recognized reference scenarios that provide standardized assumptions regarding energy systems, emissions pathways, economic development, and climate outcomes. Among the most widely used are scenarios developed by the International Energy Agency (IEA), the Intergovernmental Panel on Climate Change (IPCC), and various financial and policy institutions. IEA scenarios are particularly influential because they focus on the evolution of global energy systems and the implications of alternative policy choices. These scenarios provide organizations with structured frameworks for evaluating future climate-related risks and opportunities while supporting strategic planning, risk management, and disclosure activities. The IEA publishes several reference scenarios that differ according to assumptions regarding policy ambition, technology deployment, and emissions reductions. Examples include scenarios aligned with stated government policies, announced climate commitments, and pathways consistent with achieving global net zero emissions. These scenarios examine future energy demand, fuel mixes, electricity generation, carbon emissions, and technology adoption. Organizations frequently use IEA scenarios because they provide detailed sector-level insights and are widely recognized by investors, regulators, and climate risk practitioners. Other important reference scenarios include IPCC Representative Concentration Pathways, RCPs, Shared Socioeconomic Pathways, SSPs, and climate scenarios developed by central banks, supervisory authorities, and international organizations. Organizations face several important choices when developing and applying climate scenarios. One key decision involves selecting the appropriate time horizon, since climate risks often emerge over decades rather than traditional business planning periods. Another consideration is the choice of climate pathway, including whether to evaluate orderly transitions, delayed transitions, or higher emissions futures. Organizations must also determine the geographic scope, sector coverage, level of analytical detail, and material risks to be assessed. Scenario selection should reflect the organization's business model, asset base, exposure profile, and strategic objectives. Multiple scenarios are typically used to capture uncertainty and improve resilience under alternative future conditions. Scenarios and models play a central role in assessing transition risk by examining how policy, technology, market, and behavioral changes may affect economic activity and corporate performance. Transition risk analysis often incorporates assumptions regarding carbon pricing, emissions regulations, energy costs, technological innovation, consumer preferences, and decarbonization pathways. Organizations evaluate how these variables may influence revenues, operating costs, capital expenditures, asset values, and competitiveness. Financial institutions may model the impact of transition scenarios on loan portfolios, investment holdings, and sector exposures. These analyses help identify vulnerabilities, assess potential losses, and support strategic decisions regarding capital allocation, business transformation, and climate risk management. Scenario analysis is also widely used to assess physical climate risk. Physical risk scenarios evaluate how climate hazards such as floods, hurricanes, droughts, wildfires, extreme heat, and sea level rise may evolve under different climate pathways. Models combine climate projections with information regarding asset locations, exposure levels, and vulnerability characteristics to estimate potential impacts. Organizations use these analyses to evaluate operational disruptions, infrastructure damage, supply chain risks, insurance exposures, and adaptation requirements. Because physical risks vary significantly across regions and time horizons, scenario analysis often requires detailed geospatial data and climate model outputs to generate meaningful assessments of future climate-related impacts. The value of scenario analysis lies not in predicting a single future outcome, but in helping organizations understand a range of plausible climate futures. By evaluating both transition and physical risks across multiple scenarios, decision-makers can identify potential vulnerabilities, assess resilience, prioritize risk management actions, and develop adaptive strategies. Scenario analysis also supports regulatory expectations, climate-related disclosures, enterprise risk management processes, and long-term strategic planning. As climate uncertainty continues to influence economic and financial systems, organizations increasingly rely on scenario-based approaches to improve preparedness, strengthen governance, and make more informed decisions regarding investments, operations, and sustainability objectives.